Hello, boys and girls, and welcome to Lesson 6-6, the distributive property. This lesson can be found on page 485. Now, we've practiced using the distributive property in class before, but we've never referred to it as the distributive property. So this might be a bit of a review to you. It might come a little bit easier than you think. Let's look at the real world link, baseball. 3 friends went to a baseball game. Each ticket cost $20, and all 3 friends bought a baseball hat for $15. So we're seeing that they each bought a ticket for $20, so that's 20 plus 20 plus 20, that's $60, and they each bought a hat for $15, so that's 15 plus 15 plus 15, or 15 times 3, is 45. So we have $60 plus $45, that's $105, correct? But we know that the 3 friends is what we have in common. Okay, so make sure that we know that the 3 is what's in common for the 20 and for the 15. That's what's in common. So let's see. What does the expression 3 parentheses 20 plus 15 represent? Well, this is how we would write it as a sentence, because we know that each one of them spent $20 and $15, the ticket and the hat, right? Each one of them. So this is what one person spent, but all of this is times 3 because it's 3 friends. So the 3 represents the 3 friends. The 20 represents the price of a ticket. And the 15 represents the price of a baseball hat. So we know that they each bought a ticket and they each bought a hat. So this together is what they bought, and there's 3 of them. So it's 3 times all of this. And that's what we call the distributive property. We've distributed as so. We've written it down as a number expression. Now let's evaluate. We have 20 plus 15. Remember, we do parentheses first according to order of operation. And here we have $35, right? $35. And we know that that $35, right, that same needs to be multiplied into 3 so we can find the total, the overall total, right? They each spent $35 and it was 3 of them. So 3 times 35. And we get 105, correct? So what does the expression 3 times 20 plus 3 times 50 represent? Well, remember, if we were to do order of operation, we would do the multiplication first, and this multiplication as well, and then we would add it all together so we can get our final. Well, 3 is 3 friends bought the tickets, so 3 times 20. 3 people bought tickets. And 3 people, the same 3 people, bought the hats, and then we add it all together lastly. So 3 times 20 represents the price of 3 tickets, and the 3 times 15 represents the price of 3 hats. Go ahead and copy those down. So now let's see, evaluate the expression 3 times 20 plus 3 times 15. Remember, order of operation dictates that we must multiply these before we add both of these expressions. 3 times 20 is 60, and 3 times 15 is 45. And now we have to add them, where we have our 60 plus our 45 equals 105. Yes? So what do you notice about the answers to exercise 2 and exercise 4? Well, we notice that the answers to 3, parentheses 20 plus 15, or you can say 3 times 20 plus 15, or 35, 3 times 35, is the same as the answer to 3 times 20 plus 3 times 15, right? So here we've taken this expression, and this is the way their story was written. The story told us that 3 friends, right? 3 friends bought 3 tickets, and those same 3 friends bought 3 hats. This is the order that the story was told. But we're going to take this story and go one step further and use the distributive property to turn into this. We take what they spent, we add that together per person, and then we multiply it times 3. So in short, the distributive property. In words, to multiply a sum by a number, multiply each addend by the number outside the parentheses. Okay, so we first want to add the totals and then multiply it. So example, we have 2 times 7 and 2 times 4. 2 times 7, 2 times 4. You see that? Or we could just add 7 plus 4 is 11, and then we have 11 in here times 2, which would be 22. And you notice that if I do 2 times 7, I get 14, plus 2 times 8, 2 times 4 equals 8, and 8 plus 14 is going to give me 22. So they're both going to give me the same answer. but this is called distributive property, when you multiply the outside number with each number inside. So 2 times 7, 2 times 4. The expression 3 parentheses 20 plus 15 and 3 times 20 plus 3 times 15 show how the distributive property combines addition and multiplication. We're going to combine the addition and then multiply it all together. So example 1, find 9 times 4 and 1/3 mentally using the distributive property. Using the distributive property, we would separate these because we know it's 4 plus 1/3. You see it right there? 4 plus 1/3. And it's multiplied. So we have 9 times 4 and 9 times 1/3. Remember, when we multiply a number times a fraction, we get the fraction of the number. So what is 1/3 of 9? It's 3, right? So now 9 times 4 is 36, plus 3 equals 39. And make note, maybe this will help you remember why it's called distributive property. We have it clumped up as so, and when we use the distributive property, we're distributing this 9 with the 4 to multiply by the 4 and by the 3rd. You see, we've distributed, we've separated it. Okay, so let's go ahead and write these down, and then you can watch me do the first one, and then maybe you can pause and try B and C on your own. Or if you're ready to do all 3 on your own, go ahead and do it. So watch. I'm going to take my 5, and it's times 2, right? Because I'm breaking up this. I'm distributing the second expression. Plus, I'll take my 5 again and multiply it times 3/5. And you know that 3/5 of 5 is still 3. So that's going to give me 10, right? 5 times 2 is 10, plus 5 times 3/4. What is 3/5? 3/5 of 5 is 3, right? And I get 13. You can pause the video now and try these on your own. Remember to separate this expression. It would be 12 times 2 and 12 times 1/4. And over here would be 2 times 3 and then 2 times 6/10 is the same as 3/5, as we have here. Don't forget. So I've used distributive property to break this up. I've distributed, and I have 12 times 2, which is 24, plus 1/4 of 12 is 3 again. Okay, and now I have 27. Okay, and remember I've separated it right here, where I've separated this into, you can also rewrite this expression as 3, right, and 2/5. Sorry, as 3/5. That should be a 3. 3/5, right? 3 and 3/5. Because you simplify it 6/10, right here, 6/10. Okay, so 2 times 3 is 6, plus, now if you forgot how to multiply fractions, or how to get 3/5 of 2, simply write it as 2 fractions. You can put this one over 1. So now I'm multiplying 2 times 3 is 6, yes, is 6 right here, and 1 times 5 is 5, and now you change that into a mixed number. How many 5s do you have in 6? You have one of them, so I'm going to write it right here. I have one of them, one left over, or 5, 1 and 1/5, and when I add them out, I have 7 and 1/5, or what is 1/5 written in the 10th place? Well, we would have to turn this to a 10 to write it in the 10th place, and this to a 2. If you double this, you must double this. So it would be 7.2. Now, we're going to start using variables. There's a number in our distributive property, in our number expression, that we don't know the value of. Okay? But we can say that there's x plus 3 is repeated twice. You see that? X plus 3 will be repeated 2 times. Okay? And you can see it, x and 3, x and 3. That's how it will be written using tablets. Now we're going to use distributive property. There are 2 x plus 3. So we can say there's 2 times x and 2 times 3. So we write it as, because we can't multiply 2x, we don't know what x is, so we just write it as 2x plus 6, because we can multiply this. 2 times 3 is 6. Let's try it. If you think you're ready, go ahead, pause the video and try these now. So it looks like this. 8 times x, you see that? 8 times x plus 8 times 3, right? Now, boys and girls, you don't have to write it like this. You can skip this step if you think you're ready, but and go ahead and just jump to doing this step where you do 8 times x and 8 times 3, and then you give me the answer, where it would be 8 times x is 8x plus 8 times 3 is 24. Okay. Then the next one, 5 times 9, I know what 5 times 9 is, 45, and 5, so that was 5 times 9, and now 5 times x plus 5x. See? And over here I have 2 times x, so it's 2x, right? And 2 times 3 is 6, plus 6. And there you go. Okay, here's an example for example 3. For the sake of saving time, please read it through. Take a look at how they distributed the numbers, okay, and how it's lined up. Please, this is for your own benefit. Pause the video and read it here or read it on your book and try to make sense of it. Don't forget that the idea is to try to get you to learn how to work with just the textbook, okay, because that's what you will be doing in the next couple of years, just working directly with the textbook and doing some self-teaching. So this is part of the, or self-learning. This is the part of the self-learning. Okay, so pause the video and practice reading through this and make sense of it. Alright, I hope you paused the video. Let's try this one together. Each day, Martin lifts weights for 10 minutes and runs on the treadmill for 25 minutes. Each day he lifts for 10 and runs for 25. Write 2 equivalent expressions and then find the total minutes that Martin exercises in 7 days. So the first question is asking us to write 2 equivalent expressions. Equivalent means the expressions will give you the same answer. They will be equal, okay? They will give you. So I know that he's doing for 7 days, right? He's lifting for 10 minutes. And for 7 days, he's also running for 25 minutes, right? That's what it says there. 10 minutes and weights, right? Weights, and then he runs for 25 minutes. And there it is. Right? That's an expression. And when I solve for this, I'm going to get 7 times 10 is 70 minutes, plus 7 times 5, times 25 is going to be 175. Okay. And when I add the 2, I'm going to get 245. Okay? So that's one expression. Okay, that's one expression. And I'm going, expression. And I'm going to do the other one. The other one would be, because I know that the 7 is the common factor between the two, it's a common factor, right? I'm multiplying it here and I'm multiplying here. So it's a common, it's in both, factor. I'm going to take that 7 right out, and I'm going to put it outside the parentheses. And inside the parentheses, I'm going to put the amount of total time that he does every day, which is 10 minutes plus 25 minutes. And I know that that's going to give me 35 minutes in total, right? And it's times 7. Each day he does 35 minutes for 7 days. And that's also going to give me 245. And there's your 2 equivalent expressions. I exercise lifting weights 10 minutes a day for 7 days. I know that when it's factored for me, it's 70. Right, it's 70 minutes, because I just said it here. I'm going to put it on the side so you understand what I said. I did 7 days for 10 minutes a day. Okay, I have to multiply 7 days for 10 minutes, and that's going to give me 70. If they just write the 70 for me, saying 70 minutes, it's already been factored for me. It's already a product. You see, it's already been multiplied, and it's already a product. And then they tell me that I do 25 minutes. I do 7 days. I also do 25 minutes a day of running. And if it's already factored for me, it's going to be 175, as we just did in the previous. So if something is written in this expression, it's already been factored for me. Now what we need to do is the next step and look for what it was factored with, the greatest common factor. And when I look here and I look here, I believe the greatest common factor, or what they gave us, was 7, and that's not necessarily the greatest common factor, but we know that they were both multiplied by 7, and I know that one was 25 and the other one, one was 10 and the other one was 25. So we're trying to go from this to this.